That is the only thing I've ever done that made me feel like a bad person. So, don't share that. Let's knock it out. Today, we're going to get a head start, and we are nearing, not quite there, but nearing the end of the chapter. As we look, today we get to start 2.5, where our focus is going to be on a very specific way to solve and set up problems. It is referred to as completing the square. Now, when we are doing this, we are trying to make perfect square trinomials. And just as a quick throwback right now, if I gave us two functions, and I don't need you to graph right now, but I'm going to just do a quick optional if you want it. The quick question is, which of these would you rather graph? If I said make a table, graph it, you could do f of x equals something in standard form. So we'll do like x squared plus 2x plus 1. You could graph this, or you could graph that same function, and these are identical, they just look different. You could graph x plus 1 squared. Which of these would you choose to graph if I said you have to make a table, identify the vertex, show me your points, and plot it? I'm going to give you like 30-ish seconds. Chat with your neighbors, and we'll come back together. Just to be really clear, we've seen both of these things this chapter. It's a super long chapter. But we have standard form, and this one's called what? Okay. So, quick show of hands. And there's not really a wrong or right, although I think there is, but not exactly. How many of you would rather graph in this standard form? Okay. So, follow-up question, where's the vertex at? So, how do I find the vertex? Negative b over 2a, and then you have to plug that in and see what spits out. Okay, you could do it. I agree. Where's the vertex on this one? So you say right there, and I agree, but what do you mean by right there? I heard several answers. What's the h value here? Is it 1 or is it negative 1? The vertex here is negative 1. It's the opposite. And what's the plus k out here? I can do the vertex super quick, super easy. I think that this is the easier form to graph from. Now, whether or not you agree with me, it's up to you. It doesn't really rub me wrong either way. This one, you could also graph. These are the same function. This one's much nicer to graph, though. Now, if you look back at the stuff that we did, and we'll, of course, do a review for this, but we graphed in this form, and that was like 3.2. But we also graphed in this form in 3.1. And the connection that we're going to be showing or hitting with completing the square is how do we go from something that's hard to graph like this and change it so that it's something super easy and nice to graph like this. And it turns out the answer is known as completing the square. So as we get in with this, we are just going to define this real quick and immediately jump in with some examples. So here we go. I should have just done this as a single piece, but it's going to be a little bit redundant. Sorry. We're going to define completing the square. Complete the square. Okay. This whole process, all that it really represents, and literally all that it represents, not what it essentially does, what it exactly does. This thing takes a quadratic in this general form here, takes a function, and I'm just going to say it takes y equals ax squared plus bx plus c, and produces, instead of this more generalized form right here that's really nice for factoring and stuff, it produces this same equation, but it produces it in this form, a times x minus h squared plus k. This is the process of how do we actually go through getting to vertex form. And if you're good at it, graphing this problem is doable. It might take you a few minutes to get everything set up. It'll take you less time to just convert it and then graph it from there. There's value here in efficiency, but there's also value in maybe developing another way to solve quadratics that we just don't know how to solve right now. Okay, so for this, here's what we're going to do. We're going to just jump right in, and we're going to just fill in the blank. So fill in blank for perfect square. And this is very caveman speech, but I don't want to be super wordy with it. Okay. Now, we're going to do a couple together, and then we're going to see if you guys can help me write the rule. So for these ones, we'll just jump right in. If we have something that looks like, I don't know, x squared plus 7x. I'm going to change that to an 8 because it's easy enough to change. And there's a reason for this. I promise it's not pointless. Okay, I'm going to rewrite it because I hate the way it looks. 8x plus blank. Now, as we look at this, if you have a picture in mind and you've done the algebra tiles and stuff, this is not a square yet, but it's about to be. Now, my first thought as I'm looking at this is if we think back to that rule from the bell ringer, we can work backward from it. And it's tough to do this first time. We're going to get a lot of practice with it. What numbers could I possibly put here? And we're going to get a bunch of the wrong ones first, I think, and I'm cool with that. If we have a perfect square trinomial, and I go back to the bell ringer from today, and I'll go back to it again, I needed the square root of the first one. I needed to have the square root of the last, so it has to be a square number. And then there's this relationship here. So whatever this and this multiply by, we have to double it to get here. So we're just going to play around with this and see if we can stumble upon the right one first without a whole lot of focus on it. Give me some square numbers. Okay, give me a smaller square number first. Okay, 9 might work. Now, I'll tell you, it doesn't, and some of us can see it right away. If I tried to do the same thing, could I do the square root of this? It's x. Can you do the square root of this? 3. If you multiply these and double it, do you get 8x? No. Bummer. Okay, so we'll try again. If it wasn't 9, there was another suggestion that I ignored. If we did 16 instead, the square root of this is still x. What's the square root of 16? 4. If you multiply these, we get 4x, and if you double it, we get a what? Hey, that works, right? By doing this, finding out that it's 16, we have a nice way to make this thing perfect. Now, I didn't say to factor it, but just to get the practice, if I can find this number 16, and I find this and this and this works, is there an easy way to factor this? What were the square roots that we found? So 4 is one of them, and x is the other. What's the sign on that middle term? Plus. We have made a nice, perfect square trinomial. Okay, it takes practice. There's a rule hiding behind here. Should we try another one together, or do you want to try a couple on your own? Okay, so x squared plus, we'll make it, I don't know, 18x plus blank. And then on C, we're going to do x squared minus, now we'll do that 7x plus blank. I'm going to give you guys a moment. I'm going to be honest. Guessing and checking, valid way to do math. It's not very efficient, but it is a completely valid and okay way to do it. We're going to clean up the efficiency. We're going to see if we can find some connections here. I'm going to give you guys a couple minutes. I'll be walking around. Don't sit and just wait for the answer to show up on the board. Try some square numbers here and see if we can find one that works. This one's harder. Cool. I'll give you guys a moment. But I am hoping that it comes out to be an 81 right here. And a lot of people that I came around and looked at, this is what you had on your page. Talia, I liked what you told me. How did you know 81? What Talia recognized is that if we think about it almost like grouping, if you take the square root of this, it's 9, right? And if you do 9 plus 9, you get 18. If you take a square number like 16 and do 4 plus 4, what does it give you? 8, indeed. This one's harder. You need square numbers that add up each piece to a 7. That's pretty gross, right? Now, there is something working here, and I've heard people saying it. Did you do this in Algebra 1? Okay, if you did, awesome. If you didn't, even more awesome, because you guys, I'm here to all the pieces floating behind. Okay, does anybody have an answer on this term? What do you get, Hawaii?
For C term?
Yep.
49 over 4.
49 over 4. Well, of course it's 49 over 4. It does work, and I'm just going to check. What's the square root of x squared? Now, of course it is, was me being kind of like joking. There's not an obvious choice here. This is a much harder problem. Nice job, Hawaii, by the way. Okay, x. What's the square root of this? So I'm sorry, the whole thing. 7 over 2. And then if I wanted to take these, and this is ugly, I would not write it, but this is 3.5, right? If you double 3.5, what do you get? Hey, that works exactly like the others. When you factor this, the only thing that we need to do is pick this sign. How do I make the determination of this? The middle. This is a minus 7x. So we just drop that sign right down. There's our factored form. Now, there is a shortcut at work here. We should factor this one. What's the square root of the first and the last? X and 9, and then that's a plus. We have even a faster shortcut in this situation. Now, whether or not it's really faster, I don't know, to be honest, but it's here. What I want to do then is from these. Most people had this. Most people had this. At least 2 people had this. Anybody else come up with 49/4? So that's all right. Now, I want to see if there's a way that we can work this out in general. So for our next little piece, we're going to generalize a rule. So generalize a rule. And there's a couple things that I do want to point out. We don't have to physically write them down right now. On each of these 3 examples, what was the leading coefficient? 1. It was a 1. Okay. Keep that idea in the back of your mind. We're probably going to use that again. Okay. As we're looking at this, these are fine. They're nice. They're concrete examples that work really well. But we want, instead of working with these, we're going to start with the most general form of this. So let's say we're given a quadratic, and we'll just write it as y equals ax squared plus bx plus blank. And it's annoying, I know, to have a blank there. I don't know if you need to underline it or not. I would put something to show that there's a blank number missing. Okay, if we are given this, which is exactly what we had up above. Now, with a equals 1, and we'll just specify that that was a nice convenient thing that happened, we have the following rule. If we want to find this term, I heard a lot of people talking about multiplying by 2 and things like that. But we're going to do the same thing. Multiplication and division, are they the same thing? I would argue yes, they undo each other. It's just a multiplication that undoes it, right? Dividing by 2 is the same thing as multiplying by 1/2 or 0.5. So check this out. We can think from this term and think back to say, oh, well, what square number has roots that add up to this? Like, that's a fine way to think about it. But we can just switch the direction. If 2 of the same number have to add up to this, I can find that number by dividing this by something. If we divide this by 2, I think I get the same answer, right? If you take 8 divided by 2, what is it? 4. And now square it. 16. If you take 18 divided by 2, what do you get? 9. And square it. If you take 7 divided by 2, don't say 3.5, we get 7/2. And if you square it, what do we get? 49. Hey, there is a rule. Now, all we want to do is just take that rule right there and just generalize it. We fill this blank, we need, or we, you know what, I'm fine with need instead of want, a term in the blank. Okay, specifically, this is like my C value. I'm going to say blank, and we'll just call it C, because ax squared plus bx plus c. Specifically, this term that we need here can always be found by taking, which term here did we divide by 2? Just the b. And you're right, it's the bx, I agree with you. But the only thing that I care about is the number b. And then we did what to it? Divided by 2, and then one more little piece. We square it. Every single time this is going to work. Now, tomorrow in class, we're going to start playing around with these. We're not just going to use it to find this nice form here. We're going to actually start solving some equations with this same technique. Cool. All right. We have about 20 seconds. You guys can start packing up. I'm open to alternatives. You come talk to me at lunch. If you cannot go to the band concert and you still want a 10 out of 10 on an optional homework assignment, come talk to me, suggest something, and I'll tell you yes or no. Cool. I'm here at lunch. I'm here after school. Don't forget, I'm the coolest person you'll meet all day.